um, number 7 first. And as always, if you feel like you want to, I encourage everyone to answer the questions in the chat. If you feel particularly like you don't want to put that out there, you can always respond to myself or Caleb privately just to check your answers, or you can just kind of talk amongst, go over it by yourself, and then I'll give the questions or the answers eventually. So let's go ahead and look at number 7. We'll see how many of these we get through today. So number 7 says Boyle's law states that at a constant temperature, the volume of a fixed amount of gas varies inversely with the pressure exerted on the gas. Therefore, the volume of a gas blank when the pressure on the gas increases. Okay, so a couple things here. As usual, right, I like to mention that you get a question like this, it sounds harder than it is. Trust that the answer to the question is in there, right? It's not like some kind of knowledge that you have to have remembered or be able to pull out of the back of your brain. Like, it's all there for you. So that's why I always emphasize with science and social studies, it's not about how much you remember, it's about how well do you know vocabulary and how well can you answer questions. Okay, because the information is there and they give you the information you need. That's the same on all these questions. So the key vocabulary word here is inversely. If you don't know what inversely is here, then you're going to have to do some guessing or some, you're going to have to figure things out a little bit. So it says that at a constant temperature, which just means if the temperature stays the same, the volume or the three-dimensional amount of space taken up by a gas varies inversely with the pressure exerted on the gas. Okay? So if you were here, I think maybe even on the very first day of class, we talked about states of matter, and we talked about this exact thing a little bit. So we want to know, does the volume of a gas increase when the pressure on the gas increases? Does the volume of a gas decrease when the pressure on the gas increases, or does it remain the same? So if you remember this, then the answer might be easy. If you don't remember this, then again, the answer completely lies on, do you know what it means to vary inversely? Right? Or what is the inverse of something? So in math, we use the term inverse often. But here, we're talking about the opposite. Okay? So to vary inversely means to be the opposite. So if you don't have any knowledge of any of this other stuff, but you know that inverse means the opposite of, then you'll answer this question easily. The volume of a gas, blank, when the pressure on the gas increases. So if pressure increases, then the volume of the gas must be what? Decreasing, right? And that's all that we're looking to get here, right? But if you think about it logically also, and remember when we talked about gases, they are the one state of matter. So we have solid, liquid, gas. Solids and liquids, their volumes can't be changed, right? You can't take a brick and squish it and make it smaller. You can't take a glass of water and smush that water down and have less water. But you can with a gas. And the thing that varies the volume, or the thing that changes and manipulates volume with gases, is pressure. So if you have a lot of pressure, you can squeeze that gas down to a smaller amount, right? A smaller volume. Or if you release the pressure and you let off the pressure, the gas will expand, right? So think about a pressurized oxygen tank, right? If the oxygen in that tank is super pressurized, that means there's lots of pressure being applied to it, and it's relatively small and it's condensed. You can fit a lot of oxygen gas in one of those small containers because the pressure is great. If you undo the valve and let off the pressure, that oxygen goes and fills up this whole room. It goes away quickly. So again, that's more time than we needed to spend on it. So let's look at number 8 and number 9. They deal with the periodic table, and specifically this chunk of the periodic table that they give us. Okay, So we talked a little bit about the periodic table, but again, if it's something you don't remember, it's okay. Right? I don't expect you to remember everything we talked about when it comes to the periodic table. So don't expect to know everything that they're asking. Trust that the answer is in front of you. Okay, so the paragraph says of all, all of the elements are arranged in the periodic table according to atomic number, the number of protons in an atom of each element, right? So that's the 1, 2, 3, 4, 5, all the way, right? That atomic number just tells us the number of protons in an atom of each element, and that's the way that they're organized on the table. The rows, or the horizontal, right? Rows of the periodic table show elements according to the structure of their electron orbits. The columns, or groups, the vertical, show elements with similar properties. A portion of the periodic table is shown below. Okay. If you understood all that, great. If not, don't panic. Let's just look at the question and see what it is that they're asking us. So 8 says, group 18 is also known as the noble gases. Their electron orbits are completely filled and they rarely react with other elements. Which of the following is a noble gas? Okay, so again, don't make these questions harder than they need to be. If none of that made sense, the only thing that you really need to know is which of the following of these is a noble gas? And remember, they tell us, so they give us all this extra information that we don't necessarily care about, right? In terms of answering this question. The only thing that's important to us is identifying where the noble gases are on this table. They say group 18, so you have to look up at the thing, find 18, and know that a group, right? They mention it up here, the columns or groups. Group 18 refers to this whole group, right? So all you're doing is finding what one of these 4 elements reside in this group. In other words, are one of the noble gases. A, nitrogen, B, chlorine, C, xenon, or D, fluorine. Okay, nitrogen is over here, chlorine is here, xenon is here, fluorine is there. Only one of those elements, xenon, is in group 18. So it's as straightforward as that. Okay, so again, don't make it harder than it needs to. Now, number 9 is a little trickier. So I apologize for zooming out so far. I just want to make sure that we can all see the whole question. Right? If this is too small, then just kind of let me read it and hopefully we can answer it. This one's a little bit trickier and takes a little more thought. It says, which of the following statements is supported by the information given? All right, so let's look at our statements. A, silicone, Si, is a very common element. B, chlorine and iodine have similar properties. C, arsenic and antimony have very different properties. Or D, arsenic has 85 protons in its nucleus. So again, a lot of that stuff may be stuff that seems confusing or isn't stuff you know, but it's all up in the paragraph. So let's look at a few things, okay, and we'll kind of rule some out as we go. All right, first it says all the elements, and I'm just reading the paragraph, all the elements are arranged by atomic number, or the number of protons in an atom of each element. Stop there, okay? Look at D. Arsenic has 85 protons. Find arsenic, As, on this chart. Where is As? Right here. As. What is its number? 33. So that is the atomic number, which means that arsenic has 33 protons in its nucleus. So D is wrong. Throw it out. Okay. Let's look at C. Arsenic, As, same thing, and antimony, Sb, here's Sb, here's As, have very different properties. So where does it say anything about properties, whether it's different properties, similar properties, right? Because B talks about similar properties, C talks about different properties. How do we know whether an element has similar or differing properties? Okay. It says the rows of the periodic table show elements according to the structure of their electron orbits. So that doesn't apply. So rows aren't what we're looking at. But it does say columns or groups show elements with similar properties. So that implies things that are in the same column should have similar properties. Things that are in different columns should have different. Simple as that. So C, arsenic and antimony, they're in the same column. So they should have similar properties, correct? Right? So C, arsenic and antimony have very different properties. False. Get rid of it. All right. Now we've got A, silicon is a very common element. B, chlorine and iodine have similar properties. All right, so here's silicon. And in general, the lower the number, the more common it is, but that's not always the case. And it doesn't say that anywhere on here. So you can't assume that just because you think you might know silicon is a very common element, even if that's true, it's not supported by the information given, right? Which is what the question says. The only one that actually is supported, based on the information we know, is B. Chlorine and iodine have similar properties. I and Cl are in the same column, so they must have some similar properties. Okay? All right, moving on. Let me see how we are. Moving on time. Okay. Let's look at 10 and 11. And again, these are all good. I like a lot of these practice questions because they're all questions that deal with topics that seem confusing or seem like, you know, I don't know. We didn't talk about electromagnetic spectrum, and that's true. We didn't. You don't need to have any knowledge about the electromagnetic spectrum to answer these questions. All you have to do is be able to read the paragraph and look at the graph and answer the question. I'm just trying to beat that into your brains. You see something that doesn't look familiar, don't panic, right? Because when you see something you don't know or don't recognize and you're taking a test, the first thing you tend to do is panic because you're like, oh crap, I don't know what they're talking about. Take a breath and remind yourself, it doesn't matter, right? Trust me. I've seen enough people pass the science test and the social studies test to know that that's the case, right? Like I've mentioned before, science is the one test people have the highest success rate. You go to take the science test, chances are you're going to pass. Just have confidence when you take these tests, when these practice. All right, so number 10 talks about this electromagnetic spectrum visual aid and then the little paragraph. So let's read the question and then we'll maybe bounce around and look at it. 10 says, which of the following types of electromagnetic radiation has a wavelength longer than those in the visible spectrum? So, first we need to find out where the visible spectrum is and where these various types exist on that. Okay, so let me jump back up and let's read the paragraph together. It says, electromagnetic radiation consists of electric and magnetic fields that oscillate back and forth. There is a wide range of types of electromagnetic radiation, which together form the electromagnetic spectrum. Well, that wasn't very helpful for us in terms of answering number 10. So let's look at the thing. So we see this graph that shows us wavelengths, right? And we've got smaller to bigger wavelengths, or shorter to longer, okay? Now, the question says, which of the following has a wavelength longer than those in the visible spectrum? So the next thing to do is find where the visible spectrum is. So notice where it says visible spectrum, and we see the colors, violet all the way to red, right? That visible spectrum is just this little tiny part right here, right? So everything shorter than that and longer than that isn't visible to humans, okay? So now it's just a matter of finding which one of those four things is on this side of the visible spectrum. In other words, longer. Microwaves, okay, microwaves is there. Like the right answer. But let's double check. Ultraviolet, X-ray, and colored light. So where's colored light? It doesn't really mention it, but we know colored light is referring to this. Colored light is in the visible spectrum, so it's not. X-ray and ultraviolet light are shorter than. The only answer that makes any sense is microwave. All right, let's look at number 11. Which of the following generalizations is supported by the diagram? In other words, which one of these statements is proven or is likely to be true based on the information we know in the paragraph and in the diagram? A, unlike people, some insects can see ultraviolet light. All right, is there any information on there that tells us insects, anything about insects or their visible field? No. Throwaway answer. B, warm colors like yellow have a shorter wavelength than cool colors like blue. Okay, let's look at that. So remember, this spectrum goes from short on the left to long on the right. Same thing applies to this little tiny visible spectrum. So that means violet is the shortest wavelength, red is the longest wavelength, right? So it says warm colors like yellow. So here's yellow, have a shorter wavelength than colors like blue. Okay? Blue's on this side, yellow's on this side. That means blue has a shorter wavelength than yellow. So B, wrong. C, people can see only a small portion of the electromagnetic spectrum. So the visible spectrum is just this. But we have all these different wavelengths that aren't visible. So C makes the most sense, right? And just to make sure that we're not missing something, D, in medicine, X-rays are used to make images of bones. Okay? Again, it doesn't matter whether it's true or false or a correct statement or not. It's not something that's supported by the diagram. It doesn't mention anything in there about medicine, right? Or imaging of bones, right? We just associate X-rays with imaging of bones, and so that sounds like, oh, maybe that's the right answer. But it doesn't say or show us any reason to think that that should be the right answer. So, all right. And again, I don't recommend that you all take this much time on practice questions. That's not the purpose of me going through it, right? The purpose of these is just to be thinking about how to go ahead and answer questions on the test. So if you take even some of these little tips or techniques, hopefully it helps you on the test. That's all I'm trying to do. Okay? That is the main object of my over-analysis of practice. So let's move ahead, and I do want to do 12 and 13. So we're going to do these two, and we'll see. I've got a few more that I want to do. We've got about 10 minutes left, so let's just go through these. If you're tired of listening to me talk, you can always mute me and just do the practice questions. I promise I won't. Can't see or hear you anymore. Complaining won't bother. All right. So let's look at number 12. This talks about weight and mass, which is something we talked about a couple days ago. It says objects are attracted to one another by the force of gravity. Gravity is proportional to the mass, in other words, the amount of matter that an object has. Gravity decreases as the distance between the objects increases. As you get further away from something, gravity decreases. An object's weight is a measurement of the Earth's gravitational pull on that object. Remember when we talked about the difference between mass and weight, mass is how much matter something is made up of, and weight is your mass or the object's mass in relationship to the gravitational. So, what happens to the mass and weight of a rocket as it travels beyond Earth's orbit? So, this is similar to the example we talked about when I talked about if you were to go from Earth to the moon, how that would affect your mass and how that would affect your weight. So, remember, it says that weight is subjective to gravity, and gravity decreases as you get further away from something. So, if a rocket travels beyond Earth's orbit, getting further and further away. So, that means what is happening to the rocket's weight? Let's talk about weight first, and then we'll talk about that. Right? In theory, if that rocket is getting further away from Earth, its gravitational pull, or Earth's gravitational pull on that rocket is less. Therefore, the weight should be less. Okay? Remember, if you go onto the moon and you step on a scale, you're going to see a number a lot smaller than you see on Earth. You are way, way lighter on the moon than you are on Earth. It doesn't mean you're tinier. Right? It just means you're lighter. Okay? Now let's talk about, so we know we're looking for something in here where the weight decreases. So I see A, weight increases, right away I throw it out. B, weight decreases, okay, so that's good, that's an option. C, weight decreases, so that's an option. D, weight remains the same, throw it out. We know if we're getting further away from Earth, our weight should be getting less, right? According to the description they give us. So A's wrong, D's wrong. Now let's look at B and C. Because the difference with B and C is how it talks about mass. So weight is decreasing in both of these, but B says its mass remains the same and its weight decreases. C says its mass decreases and its weight decreases. B is saying mass stays the same, weight decreases. C is saying they both decrease. So remember, back to our example about talking about standing on the moon. If you go and leave Earth and stand on the moon, is your mass actually decreasing? Are you getting smaller? No. Your mass is not impacted by gravity at all. The mass is just how much matter are you made up of, or the rocket, right, in this case. How much matter is the rocket made up of? And that amount of matter doesn't get smaller just because your weight is less because gravity is less. So the right answer is its mass remains the same and its weight decreases. All right? Make sense? Okay. So 139. Let's at least do this question and then maybe we'll stop there. I had a couple others I want to do, but I don't really know. Okay, let's look at number 13. This is something we kind of briefly talked about if you've been in class the last week. It says, heat energy can be transferred from one object to another. In summer, when you hold an ice-cold can of soda against your face feels cooler. However, what is really happening is that the can is being warmed by heat from your body. You are actually losing a little bit of your body. Which of the following is an unstated assumption related to the paragraph? Okay, so let's break this down a little bit, and then I'll talk about what they're describing. Because again, you don't need to know exactly what they're talking about. You just need to find the right answer. So we're looking for an unstated assumption. When something is unstated, what does that mean? Does that mean it's specifically mentioned in the paragraph? No, right? If something's unstated, it's not said. It's not mentioned specifically in the paragraph. So our answer is going to be something that isn't mentioned in the paragraph. Okay? So that should help you eliminate some possible answer choices. All right? A, heat can be transferred. The first sentence says heat energy can be transferred. Is that unstated? No, that's directly stated in the paragraph. A is wrong. Secondly, you don't need to, but it would help if you know what an assumption is, right? So we know what unstated means. Unstated means not mentioned. Assumption is a guess or something we assume to be true, right? Based on what they tell us, right? So it's more than a guess, but I guess that's a little bit close to defining a word with the same word. But an assumption is something that we assume is true based on the information they give us. Now, it might be a false assumption or it might be true, but it's still an assumption, right? We're assuming it's correct. So we're looking to see which one of these is something that's not clearly stated, but is assumed to be. All right. Let's look at B. Coldness cannot be transferred. Okay, did they mention anywhere in there about coldness being transferred? No. Okay, so let's skip it and we'll come back to it and see if maybe it's the right answer, maybe it isn't, right? But it's not mentioned specifically. So we're not going to throw it out right away. C. A cool object can be warmed by your body. Does it talk about a cool object being warmed? However, what is really happening is that the can is being warmed by heat from your body. That directly matches what C said. C is something that is stated directly in the paragraph. Not correct. We're looking for something not mentioned. C is wrong. D, you can lose body heat. You are actually losing a little body heat. Taken right out of the paragraph. So we don't even know what the right answer is, and we've already found it just by process of elimination, because A, C, and D are all things that are mentioned clearly in the paragraph. So when you break it down that way, the fact that B maybe it makes sense to you, maybe it doesn't, it's the right answer, okay? And the reason that it's assumed that coldness cannot be transferred comes from this middle section here, where it's saying what's really happening is the can is being warmed by the heat from your body and you're actually losing heat. And that feels like coldness being transferred. That relates back to what we talked about is heat energy can only flow from objects with heat to objects without heat. Heat doesn't transfer the other way, right? Coldness is not something that transfers, right? The reason that you feel cold is because that cold object is receiving heat from your face or from your body, right? And you're actually losing some of your heat and giving it to that can of soda. And it feels like you're cooling off. And you are, because you're giving away some of your heat energy. But if you were to measure the temperature of that soda, right? If you have an ice cold can of soda and you stick it against your face for long enough, what's going to happen to the temperature of that soda? It's going to warm up because you're giving it heat energy. So whether you understand it or not, B is the answer choice. Okay, so hopefully that was helpful and wasn't just like totally overkill. I know sometimes I get especially nervous about going through so many practice questions because I worry that it's going to not be beneficial or it's going to just bore you to death. But again, we're all here to hopefully get you to pass the test. And I've just found that the best and most successful way to do it, especially remotely like this, if you can't interact, is practice. Okay. Hopefully that made some sense and was helpful. Tomorrow we will move on to a totally new topic when it comes to science. I haven't quite figured out what that topic will be yet, but it'll be new and something different. Okay, so hopefully that was good and helpful, and enjoy the rest of your day, and I will see you all tomorrow.